The topic we're going to cover today in our unit on linear functions is the concept of slope. Um, Slope is something that is associated with lines, and you have in science heard the term gradient used, uh, and it means the same thing, just used in a different context. The slope of a line is really talking about how steep the line is. And what we do in math is we like to associate the slope with a particular number value that will tell us something about the slope, how steep it is, what direction it goes, etc. Okay? Now, there are some buzzwords that are used that will help us to understand the slope besides just trying to remember formulas. Okay? Two words that we're going to use are rise and run. Rise is the vertical change between 2 points on a line. So if it's rise and it's vertical, we're dealing with the y coordinates. Run is the horizontal change between 2 points on a line, which obviously means that we're then dealing with the x coordinates. Slope is the ratio. The word ratio, you should be thinking fraction, of a line's vertical change to horizontal change. If you'll remember from the lesson a couple of days ago when we were graphing using a table of values, we saw a pattern, and that pattern was the slope pattern. So we say slope is equal to rise over run, or m, which is the math symbol for slope, is the difference in y coordinates, because if we're looking for change, it's difference, divided by the difference in x coordinates. Okay, now we have 4 scenarios that we're going to talk about when we graph lines. In other words, there's 4 ways line can be drawn. Okay, the first, if we go up to the right, that has a positive slope. That is up and to the right. If going up to the left, then that's a negative slope. And again, think about your number line. If I'm going up and right, those are both positive. If I'm going up and left, one is a positive, one's a negative. A zero slope means I'm not moving anywhere. So what type of line will have no movement? A horizontal line. Because if I were to put a ball, or if somebody were to be standing on a flat surface, there is no movement unless they create it themselves. All right? And then an undefined slope is a vertical line, because if I tried to put an object on a vertical line, it would not stay on the line, it would fall off. All right, so let's go through some examples. All I want right now is to tell me if this is positive or negative slope. So hopefully you're seeing it's going up and to the right. So it's a positive slope. Because to go from one point to the other, right is positive, up is positive. Okay? And then on the flip side, okay, I go up, which is positive, but to the left, which is negative. So that's a negative slope. One negative number makes the entire fraction a negative. Now, instead of just, let's just do two more examples and then we'll get into some numerical. So now I have two lines. One is blue and one is red. The blue line is my vertical line, so that has an undefined slope. And my red line is horizontal, that has zero slope. Don't confuse undefined with zero. Undefined is the word we have to use. It means there is no numerical value. Zero is a numerical value. All right. Now we want to figure out the specific numerical value for the slope of this line. We only need 2 points. It doesn't matter which two, although we usually stick to two that are right in a row. So what we're trying to do is, what is the way I go from 0, 1 to 3, 3? And how do I count? Well, I count up 2, which is a positive, and right 3, which is a positive. So my slope is simply 2 divided by 3. Rise over run. That is it. Going to the next example, I go up 1, 2, 3, positive 3. I go left, that's a minus 4. So my slope is negative 3 over 4. If one of the two numbers is negative, then all you have to do is write the minus sign outside the fraction. You could also put it with the 3 or the 4, as long as there's only one minus sign that shows up. All right. Lastly, now I give you 2 points. And we want to use our little formula to figure out slope. We don't want to have to go and plot. So the other formula I'm going to give you for the slope is y2 minus y1 over x2 minus x1. Now, what I've just done is put into formula fashion that change in y over change in x. And the reason I show you that is because then what you can simply do is you can say this is x1, this is y1, this is x2, that is y2, and plug them into the little formula. Okay? This is called subscript notation because the 2's and the 1's are not exponents. All they're doing is saying I got two different x's and two different y's. So y2 minus y1 over x2 minus x1. I get negative 6 over 8, which is negative 3/4. Okay? Now, just to show you for this example, if you reversed the x and the y's so that you said, I'm going to do 7 minus 1, and then if 7 comes first, the 1 comes first, over 1 minus 9, you get the same answer because it's a negative 8 but a positive 6. It's still only one negative sign. Okay? I'm going to do the next one. Again, x1, y1, x2, y2. 1 minus negative 2. Please be careful of the signs. It's a minus sign, subtraction, a negative 2. Negative 4 minus 2. That's 3 over negative 6, or negative 1/2. Okay? Next example, I have 6 minus 1 over 1 minus 1, or 5 over 0. 0 in the denominator is undefined. Okay? Next one, 4 minus negative 7 over 2 minus 2. Again, undefined. Okay? And then if you were to plot the points, you would see that you would have a vertical line. I'm going to tack on an E. So let's say I had 3, 5 and negative 2, 5. So my slope would be 5 minus 5 over negative 2 minus 3, or 0 over negative 5, which is 0, or 0 slope. And then you would see if you graph that, that would graph as a horizontal line. So what we covered today is a very important part of our equations of lines and linear equations, which is the slope of a line.